So my name is Christopher Jobity, and I'm just going to be going over my project on analyzing pathways via which septic system wastewater reaches tributaries. So septic systems act as an alternative method of treatment for wastewater, and they're typically found in rural areas where access to things like sewer systems or wastewater treatment plants aren't as readily accessible. And typically within the septic tank or septic system, you can find high concentrations of nutrients, microbes, and various emerging contaminants. So a well-functioning septic system ideally will have household wastewater be filtered via the tile bed or leaching bed, in which case it's naturally filtered via the underlying soil media underneath the system. And that treated effluent is then discharged into a nearby watercourse or stream. So with a poorly performing septic system, the septic effluent or wastewater has a more direct pathway to the watercourse, leading to untreated effluent reaching the stream. And a few ways this can happen is if you have poor filtration of the wastewater through the soil media, or you have direct pipe connections to the septic tank, or you have overland runoff. It could be due to an elevated water table or an overloaded septic system. So to go over the project objectives, so firstly is to determine how the septic wastewater is actually reaching the streams and what kind of hydrologic pathways it's taking. And this can give a lot of insight into potentially how much or the amount of wastewater that is actually being input into the stream. And secondly is to determine the contribution of septic systems to nutrient loads within nearby streams. So these objectives are carried out in 4 different study subwatersheds within the Lake Erie Basin area. And each watershed has different geologies, household densities, and also different socioeconomic characteristics. And these parameters are looked at just to see if they have an impact on the amount of septic failure that is occurring or the amount of wastewater that is reaching the stream. So at each of these watersheds, 3 different sampling approaches are carried out, and each are used to identify potential pathways that the wastewater may be taking to the stream, and also to find potential hotspots in the stream where there may be major contributions to the stream of septic effluent. And samples are run for a number of different constituents or wastewater tracers, both chemical and microbial, as listed here. So this is an example of some results from a high-resolution longitudinal sampling that we did. So we had multiple sampling locations along the stream represented by the stars on the map on the left. And between the chemical wastewater tracers, which in this case are artificial sweeteners, which are a good unique indicator to septic systems, and also the microbial tracers, you can see that there's really 2 major hotspots occurring at the stream. So there's a large increase in concentration at the upstream location here and at the downstream. And the fact that the microbial tracers have such a high concentration at these locations indicate that there's more rapid pathways of effluent reaching the stream. So in conclusion, using a combination of chemical and microbial wastewater tracers gives valuable insight to potential delivery pathways of septic system effluent. And also, septic wastewater effluent is shown to be reaching streams via rapid pathways, and typically in higher household areas. And just in terms of next steps is to continue collecting samples over different seasonalities and flow conditions to gain a better understanding of how the effluent is reaching the stream. And that's it. Thank you.